Welcome back, everyone. So today we are going to begin a conversation about how to deal with two random variables, not just one, but two. So in the past, we had one random variable. Sometimes it was quantitative, sometimes it was qualitative or categorical. And we focused a little more on the quantitative piece or side. And the analysis, the approach we took on the analysis was we discussed the general shape, whether or not the distribution looked symmetric or not symmetric, skewed left, skewed right, unimodal, bimodal. That's the kind of language we used. And then we talked about the center, we talked about the spread, and then we talked a little bit about outliers, data that seems to be outside of the norm. So today we are going to discuss two variables, and as you can imagine, the simplest relationship between two random variables is linear. So this chapter is on linear regression or linear relationship. Now, as you know, most relationships between two random variables are not linear, and we will handle those. So if we encounter later, if we encounter a relationship that looks something like this, or like this, we will have tools to basically take this curve and linearize it. We will linearize those relationships by applying certain functions on them. But for now, we are going to begin with linear relationship. We don't need to linearize them. They seem to be linear. And then we're going to talk about the analysis. How do we analyze a linear relationship, or non-linear, but the point is two random variables. Let's begin with the first things first. Couple of vocab. As you know, the x variable, by the way, we are only going to deal with quantitative variables, okay? So this entire chapter is about two random variables that happen to be quantitative, and we want to compare one against the other. So as you know, x is the independent variable. Sometimes we call it the input. In statistics, we call it the explanatory variable. The y, which is the output, or the dependent variable, in our case, we're going to call it a response variable. It is a variable that responds to the independent variable. So that's one thing to know. Now, here on the right, I just took this from your book. It is just a bunch of data. What it does here, we really don't need to know where is this coming from. The point is to do the analysis, but let me just tell you what it is. So it's basically a bunch of football teams, college football teams, and what they decided to do is to look at the number of wins they had against the number of points per game on average, right? So for example, there is a team out there that had 2 wins only, and they had an average of about, I would say, 16 points per game. So that is an extreme. Another extreme, somewhere in here, this point, let's say, or maybe this point, this is a good one. This team had 12 wins, and they had an average of 35 points per game. Obviously, they didn't score 35 points every game, but their average is 35. And as you can imagine, the more games you win, the more likely you're going to have a higher average of points per game, right? You're not going to have so many wins with 16 points. So the more wins, the more points per game, and that's why you see this type of pattern that is sloping, in quotation marks, upward. In other words, it's not going this way, it is going this way, okay? Once again, we really don't care what these mean right now. All I care about is this data. Now, the name of this sketch is called a scatterplot. A scatter plot is just a bunch of points. We're not superimposing a line on them or a curve on them. We're not doing anything. We're just putting points as you learned in basic math course, you know, 0.1 comma 2, 0.5 comma 20, right? You just put a bunch of points. It's called a scatter plot, okay? So when you sketch scatter plots, obviously you want to have a title. It says scatter plot of fill in the blank. You need to label your y-axis, your response variable, and you need to label your explanatory variable. So this is the only thing you need to do. And then you just put those points as you did when you were young. Now, how do we proceed with the analysis? Contrary to the one random variable, the two random variable analysis, we focus on these 4 points. Now this one and this one look very similar to the one variable, to one random variable. We called it the general shape then. We call it the form. It doesn't matter. Basically, yes, we just want to get a feel for the general shape. We call it the form. And outliers is exactly what you think. So the same conversation. We're not going to have that cute rule of Q1 minus 1.5 IQR and Q3 plus 1.5 IQR. That is just for one random variable, quantitative random variable. We're going to focus on the naked eye to point out outliers. These two are very different from the one random variable. So let's begin with the form. With the form, since we are focused on linear relationships, you want to talk about words like these. I just made these up, okay? I'm sure there is more out there, but these are the ones we tend to focus on. It seems linear, it is linear, it is curved, the form is curved or scattered. So an example of linear, you know, might look something like this. It's not going to look perfect, okay? It's not going to look perfect. If it's perfect, you don't need stats. You already know the linear relationship, right? You know, like y equals to x plus 1. You know, that would qualify as linear. The one in green qualifies as curved, right? That's definitely not linear. Don't say on the green one, don't say it seems linear. No, it's not. It is so far away from being linear. A scattered, and I'll put it in red, might look like this. Something like this. That's scattered, okay? It's not even curvy at all. So that's the kind of language you use for the form between the two random variables, okay? The next piece is the direction. Sometimes we call it the association. Now, from a basic math course in like Algebra 1, you talked about slope, right? You don't want to use the word slope here, but keep the word slope in the back of your head as you address the association. So you want to talk about positive association, negative association, or positive direction, negative direction. And think about it in terms of slope. So if it is sloping this way, that has a positive association. If it is sloping that way, it has a negative association. So in here, as you can tell, the association seems to be positive, right? And also the form, it seems fairly, I would say fairly linear. It's not beautiful, fairly linear, and the association seems to be positive. So a positive association or a positive slope in quotation marks is when x moves up, y moves up. Also, when x moves down, y moves down. Isn't that true? So for example, when the number of points increase, when the number of wins increase, the number of points increase and vice versa. If the number of points, if you move in this direction, it seems to me that the number of wins also decrease, right? So both of these together tell you that the association is positive. What is a negative association? A negative association, think of a negative slope, right? A scatter plot that looks like this or like this. It's sloping in this direction, not in this direction. Mathematically, what it means, and I'll put it in green, when x moves up, oh my God. When x increases, y decreases. Or when x decreases, y increases. Think about it. If I have something like this, okay? So when x increase is, if I move to the right, the y value seems to be moving to the left. So as I'm moving to the right, the y value is moving to down, right? Moving down, not to the left. If I move to the right, and I'll put it in green, if I move to the left, if x moves to, if I am marching in this direction, the y value seems to be marching in that direction, right? So as I move this way, the y values are increasing, right? So that's what a negative association means, okay? And I'm sure you've done this in calculus. A function that is increasing, it just simply means f of x plus 1 is greater than f of x, right? Because we already know that x plus 1 is more than x. That's your input. So as x increase, the y value increase, which means the y value is bigger than the other y value, okay? So that is as far as the association. It's very, very easy, okay? Just think of slope, but don't write the word slope, okay? Now, the correlation, and this is huge. This is completely new. The correlation is a very different concept. The first thing you need to recognize is the word correlation. You don't want to say positive correlation, negative correlation. You want to say strong, weak, fairly strong, fairly weak. So when I look at this, and so what is a correlation? A correlation measures the strength of the relationship between x and y. That's what it does. And there is a mathematical way we're going to approach it. But for now, if the relationship looks like this, if the scatter plot looks like that, the correlation is definitely very strong, right? This one, on the other hand, it's not weak, but it's not strong either. It's a positive association, but the correlation, I would say, is fairly strong, not even that much, right? And I'm going to focus more on this word. But for now, the correlation measures the strength of the relationship between x and y, and the associated words you should use is strong, weak, fairly strong, no correlation. You know the scatter plots I did earlier. This one, that is so scattered. That's probably the correlation is so weak. Maybe there is no correlation at all. Okay, so in this case, I would say it's fairly strong. It's fairly strong. It's borderline between fairly strong and mildly weak, so to speak. Okay, and I'm going to focus on it. Okay, I'm going to focus on it for a long time, including today. The last one, of course, is the outliers. So if I have a point, let's say here, okay, that is definitely an outlier, right? Because most points are here. That's the general trend. And you have a point here, or maybe here, right? Those would qualify as outliers. Now, when they qualify as outliers, we can go further and talk about influential versus not influential. So we'll talk about that later. But for now, when I look at my curve here, I don't see any outliers. Do you? I don't. By the way, the reason this is maybe red, it's not because it is an outlier. It's just maybe because this is the weakest team, right? They had 2 wins with an average of 16 and a half. Maybe they had one win with 15 points and 1 win with 17 points or something. Okay, this is definitely not an outlier. It's not outside of the norm. Okay, so let's go back to the correlation, I'm going to do two things and then I will end the video. I want to spend a little more time on the correlation, and then I'm going to show you how you do the scatter plots on the calculator, because you don't want to do this by hand. It's silly. Let me erase this. Don't worry about influential versus non-influential at this point. Okay, so let's go to the last page, which is the second page. So look at these scatter plots. Okay, don't worry about the wording here. Let's just talk about it quickly. So this is a scattered, right? This is not linear, it's not curvy, it's scattered. This is also scattered. This is, I would say, scattered, but you could feel a positive association. You could feel it, okay? Not very good, not strong correlation, but definitely a negative association, right? This is fairly strong correlation and positive association, very strong correlation and a negative association. So you see these numbers underneath associated with these scatter plots, and so I want to spend a minute on them. So the correlation here, we have a number called R, the correlation coefficients. It measures the strength of the relationship, and this R tells me the whole story. Number one, R is always between -1 and 1. So that's the very first thing you need to know. Please don't confuse that with rho. You remember rho? Rho was between 0 and 1. You know, when we had the variance relationship between x and y, variance of two random variables, you know, we had variance of x plus variance of y plus 2 rho standard deviation of x, standard deviation of y. There is a relationship, okay, but it's not the same as you might think. They both measure the strength of the relationship, but this rho is always positive or 0. It is between 0 and 1. Conversely, not conversely, but R is a number between 0 and 1 inclusive. And R tells you or reflects the relationship, the strength of the relationship between x and y. If R is close to 1 and -1, it means the correlation is very strong. Now, what's the difference between close to 1 and close to -1? It's the association. So, for example, if you look at this scatter plot, it looks like the correlation is very strong, but the association is negative. So I suspect that R is going to be close to -1. In fact, it is -0.99. Okay? So try to hide these numbers and try to guess the correlation coefficients. This one is so scattered to the point that I can't even see the association, whether it is moving in that direction or in that direction, right? So most likely that R is close to 0. I don't even know if it's positive or negative because I don't have a feeling. Like negative association, positive association, negative association, positive association, maybe negative association. This one, I have no idea. So I would say it's somewhere close to 0, and ironically, it is exactly 0. Well, not ironically, but it is exactly 0. I think this is the very first one I see a correlation of 0. Now, this has a negative association and it's very weak correlation. So I would say somewhere in here, like -0.2, -0.3, somewhere in here, right? I see here that R is -0.3. And by the way, I'm not looking at my numbers. I'm honestly just guessing. Okay, let's look here. Negative association, because it is sloping in this direction, right? So we know it's going to be here. And then it's not very strong. It's not strong at all, but it's not weak either. I would say like -0.5 or something. Let's see. Okay, R is -0.7. Okay, so yeah, I'm not too far. Okay, positive association. So I know R is here, and it's fairly strong. I would say 0.8. R is 0.8. Let's see. R is 0.9. Okay, 0.8 is fine too. I changed my mind because I'm thinking of a number we're going to discuss later called r squared, and it is literally the square of little r. And so I said 0.8. That means capital R will be 0.64, and I would disagree with myself. So I agree with the book that R here is a lot more than 0.8. I would say 0.85, 0.91, something like this. They wrote 0.9, okay? Don't worry about this R squared yet, okay? Finally, which one we should do? Let's just focus on this one, okay? I don't know if I did it. Positive association, so I know I'm here, and it's weak. It's weak. I would say 0.5, 0.6, something like this. R is 0.5, okay? So I hope you get a feel for, let's go back here, by the way. What do you think R is going to be here? Definitely it's between 0 and 1 because the association is positive. Please don't say strong association, weak association. Don't say positive correlation, negative correlation. Keep those with those and keep those with those, okay? I would say R is like 0.85 or 0.9. 0.8's a little too stingy. I would say 0.85, 0.9. That's what I would say. I don't know what you would say, all right? So that's a little bit about this. I'm going to spend a lot of time on this, by the way. So this is just the first presentation. The second thing I want to do, and then I'll finish, is to, how do you do a scatter plot? Well, you already know a bunch of this. There are two steps, okay? Two steps. The first one, you need to go to stat edits, and in the past we went under L1 and we put one variable, remember? Well, now you're going to put the X under L1 and the Y under L2, which means you need to know who's who. Okay, so you don't want to put the response variable under L1 and the explanatory variable under L2. It is customary to put your explanatory variable under L1 and your response variable under L2. Make sure they have the same number of data points, okay? You shouldn't have something like this. You're not going to be able to function. So let's say L1 has 4 and L2 has 3. You're not going to be able to do anything. You must have the same number of observation, 12 each, 13 each, whatever, okay? So I know you know how to do this step. Now, how do you sketch it? Don't go to y equals. You're not graphing y equals something. You're going to go back to stat plots. Remember stat plots? The way you do it, you click on second function, y1. So that gives you stat plots, and there are like, I don't know how many of them, 4 of them maybe. Turn on the first plot. It's probably already on from previous ones. And remember we had a window of 6 type of graphs. The last one we did was a normal probability plot, and I think it was here. Normal probability plot was the last one. And I think number 3 and 4 dealt with box plots. One of them was modified box plots and the other one was not modified box plots. We have utilized 3 of them already. The one you do, the click on, is the first one. That's going to give you your scatter plots, okay? And without the scatter plots, you're not going to be able to do this 4, okay? Remember, rule number 1, sketch your data. Rule number 2, don't forget rule number 1. Okay, sketch your data. You have to sketch your data. You're not going to do the analysis. Whether you're dealing with 1 variable or 2 variables, like in our case, you're not going to be able to do anything unless you sketch your data. So in the past, we had box plots, we had stem and leaf plots. You have to sketch your data somehow before you do the analysis. So you click on the first one, and right underneath, make sure your X list is your L1, your explanatory variable, and your Y list is your response variable, L2. Make sure, it should pop up by itself, but if it doesn't, make sure you fix it, okay? And then, as most students do, they click on graph, and you might see a really nice scatter plot like this, or you might see some garbage, so which means you have to adjust your window. So here is a really nice technique. We're going to use this almost every single time in this course. Zoom statistics. If you go to Zoom 9, you either scroll down to the ninth one or literally just press the number 9 after you click on Zoom. It'll automatically set up a nice window for you and it'll show you the graph. You'll be able to see something like this or something like this. And once you have your scatter plots, you can easily address, do the analysis. Okay, so I'm going to finish now and we will take this on later. Take care.